Hello everyone, welcome to the Academics. I'm Amrita. I firmly believe that you should keep trying until we get it right. So in our previous videos, we have discussed about direct variation and also some questions from direct variation. In our last video, we did discuss about inverse variation and some basic questions on inverse variation also we solved. Now let's solve some more questions where it will require a little more mind to be used to solve these questions. So if you are watching my videos and liking them, then please like, share and subscribe to my channel Siddhi Academics to stay updated with whatever I am posting. Let's start. Okay, let's do this question. 2 men or 3 men can do a piece of work in 45 days. In how many days will 6 men and 1 woman be able to complete the work? So what is written here? Read it carefully. 2 men or 3 women can do a piece of work in 45 days. That means 2 men are as effective as 3 women, right? What 2 men can do, 3 women can do the same work in 45 days. So these are equivalent. Then how much is the capacity of 1 man in terms of woman? Definitely 1 man is as effective as 3 by 2 women, right? That is 1.5 women, right? I'll write it here. 1 by 2 women. Now, see, what is the question asking? Find in how many days will 6 men and 1 woman be able to complete the work. Now, this is the kind of question where many children get confused. So, please pay attention to this question, how I am solving this, because these questions, kind of confuse the children, because we are not talking about workers here. We are talking about men and women, their capacity separately. So when we come to 6 women and 1 woman, we have to make them come together. I mean, make them into one unit. Okay, either change the men, I mean, the capacity of 6 men into women, capacity of equivalent women, or change the capacity of that 1 woman into the capacity of equivalent men. Then only we can find how much days will be required to complete the same work. All right, so 1 man we have already found is effective as 1.5 women. So 6 men, if it comes to 6 men, I'll just multiply here 3 by 2 into 6. So 6 men are as effective as 9 women, right? So what is the question saying? That um, um, 2 men or 3 women can do a piece of work in 5 days. So 3 women can do a piece of work in 45 days. So how much work can 6 men and 1 woman do? So 6 men we found is 9 women. So 9 women plus 1 woman, right? Here it is 9 women. Instead of 6 men, I can say 9 women plus this 1 woman who's already there. So that is equal to 10 women. 10 women, which is here, I'll write here, equal to 10 women. How many days will they take to complete the same work, right? So if you see, 10 women will require less work. So this is inverse proportion. Okay, so I will mention that when number of women increase, then the number of days will decrease. So for that we have to do direct multiplication here, and here also direct multiplication. So 10 into x is equal to 3 into 45. So x is equal to 3 into 45 by 10. So what it will require is 4.5 into 3. So it will become 3 5s are 15, 1 gets carried over, 3 4s are 12, 12 plus 1 is 13. 13.5 days will be required for 6 men and 1 woman to complete the same work. So this is how we solve these kind of questions. If you have any doubts, please let me know in the comment section. This question says 3 men and 4 boys can complete a certain amount of work in 28 days, whereas 4 men and 6 boys can complete the same work in 20 days. According to the amount of work done, 1 man is equivalent to how many boys? That we need to find out. So in 28 days, 3 men and 4 boys are able to complete a certain piece of work. 3 men plus 4 boys complete a certain work. So in one day, how much will they do? Let's find first in one day how many people, right? If I have to complete the same work, okay, please try to understand. If I am trying to complete the same work, but I don't have much time, I just have one day, then how do I complete that work? I have to multiply 28, because 28 days 3 men and 4 boys are able to complete the same piece of work. So in one day, all right, I'm repeatedly writing days here, so I'll just change it to day. So in one day it will be 28 into 3 men plus 4 boys. Lot of people will be required. When it is 28 days, men and boys required are less. But if in one day I want to complete the same work, then I have to definitely increase the number of men and number of boys by how much? 28 times more, right? So here, what do? I have to multiply this. So 28 into 3 will be how much? 3 8s are 24, 2 gets carried over, 84, right? 84 men, and then here 4s are 32, 3 gets carried over, 4 2s are 8, 8 plus carried over 3 is 11. So 112 boys will be required to complete the same work. Complete same work, right? Now similarly, we have to also find out, for 4 men and 6 boys, if they take 20 days to do a piece of work, then also we have to find here as well, right? In one day, how many people will be required? So in 20 days, 4 men plus 6 boys complete a work. In one day, how many men will be required? Same as before, we have to multiply 20, because if number of days are more, men and boys required is less. If we have to complete the same piece of work in one day, definitely we need to multiply 20 with the number of men and number of boys. So 20 into 4 men plus 6 boys will give us the required quantity. So it will be how much? 120 men plus 120 boys, not 120 men. It is 80 men. 80 men plus 120 boys will be required to complete the same work. Complete the same work. So now can I not equate? I have found in one day how many people will be required to complete the same work. Now can I not equate all this? In one day, how many men and boys are required? This particular men and boys number with this particular men and boys number? Yes, I can, because I have found in one day how many number of men and boys will be required to complete the same work. Okay. So I'll equate it. Same work. Please keep in mind, not a different work we are talking about. Same work. 84 men and 112 boys can finish the work in one day. Same work, 80 men and 120 boys are able to complete in one day. So if I equate it, what it will become? 184 men minus 80 men. I'll bring this 80 men on the right hand side to this side. It will become minus. Similarly, I'll send this 112 boys to the other side. So it will become 120 boys minus 112 boys. So 84 men minus 80 is 4. 84 minus 80 is 4. So 4 men is equal to 120 boys minus 112 boys. It is 8. 8 boys equal to 8 boys. So if I divide 4 on either side, okay, by balancing method, what will become? 4 divided by 4 is 1. So 1 man is equivalent to 4 ones are 4, 4 twos are 8. 1 man is equal to 2 boys. That is what we got the equation. Okay, upon solving this, information given to us. So one man is equivalent to how many boys? The question is asking. He is equivalent to 2 boys. Let's start with the second part of the same question. 3 men and 4 boys, this is the same question, can complete a certain amount of work in 28 days, whereas 4 men and 6 boys can complete the same work in 20 days. Find the number of days required by 7 men and 6 boys to complete the same work. So we know that one man from our previous questions, because it is a continuation of the previous question, I am writing what we found in the previous question. One man is equal to 2 boys, equivalent to 2 boys in the amount of work that he is able to do. So if 3 men and 4 boys can complete a certain work in 28 days, so I'll change this 3 men to 3 men will be equal to how much? I'll first find out. 3 men will be equivalent to 3 into 2 equal to 6 boys. 3 men can complete the same work as 6 boys. So all I'm trying to find is in terms of boy, how much work can be done by a boy? I'm trying to find that first. So 6 plus 4 is 10. 3 men, okay, I'll write this because if I miss out the statement, suppose someone is not able to understand, then the entire purpose of the video will be lost. So let me write it down. 3 men plus 4 boys can complete a certain amount of work in 28 days. So it will be 6 boys plus 4 boys. So it will become 10 boys, total equal to 10 boys can complete the same work in 28 days. That means same thing. So one boy can complete the same work in how many days? He will be able to complete 28 into 10. He will take 280 days to complete the same work. There is no doubt about this because we have solved similar questions before. So I hope this is clear right now. One boy can complete the same work in 280 days, right? 10 boys can complete the same work in 28 days, means one boy will take more number of days. 10 boys work can one boy do in less number of days? Definitely he'll take more than 28 days. So we multiply 28 into 10, it becomes 280 days. So one boy takes 280 days to complete the work. Then what is the question asking? Find the number of days required by 7 men and 6 boys. So 7 men plus 6 boys. Let me express this men also in boys. So 7 men will be equal to 7 into 2, right? Because one man equal to 2 boys. So 7 into 2 plus 6. So 14 plus 6 will be how much? 20. 20 boys, 7 men and 6 boys are actually equivalent to 20 boys. So 20 boys can do the same work in how many number of days we have to find. Okay, so let me write it again. One boy can complete the work in 288 days. Now, what about 20 boys? 20 boys will definitely require less number of days because the number of boys increased. We have a inverse proportion here. So, it will be 2 into 1 divided by 20. So, into 1 I am not writing because this is inverse proportion. When number of boys increases, the number of days definitely will decrease. Inverse proportion. So, inverse proportion I have already discussed before. You have to directly multiply x1 into y1 equal to x2 into y2. So, what is the value of x1 here? 1. What is the value of y1 here? 280. So, 280 into 1. Okay, I have written now into 1 divided by x2 will give us the value of y2. So, what is the value now? 2 ones are 2, 2 14s are 28. So, 20 boys will require 14 days to complete the same piece of work. That means, I'll write here since there is space here, this is exactly the same thing. 7 men plus 6 boys are equivalent with 20 boys. So, 7 men and 6 boys require 14 days to complete the work. Okay, so this is one question. We have solved both the two parts of it. I hope I am clear with this. If any doubts, please let me know in the comment section. One more time I am repeating, whenever facing inverse proportion, you have to directly multiply, that is x1 y1 equal to x2 y2. You have to follow this formula to find out the answer. Here Y2 was the number of days required by 7 men and 6 boys, that is also equal to 20 boys. So that's why we did this direct multiplication here and found out the answer. So this question says a contractor undertook to build a road in 200 days. He employed 140 men. After 60 days, he found that only 1/4 of the road could be built. How many additional men should be employed to complete the work in time? So this is a very important question. We should learn how to solve it. So because these kind of questions really use up the entire brain capacity. So 200 days is clearly not, I mean 140 men and clearly not enough to complete the road in 200 days, because they have within within the first 60 days they could complete only 1/4 of the road. So definitely lot more additional men required to be employed to complete the work in less number of time, that is 1/4. I mean if I 200 minus 60, that is 140 days, remaining days are 140. So within the remaining 140 days, a lot more men required to be employed to get the road done. So this is clearly a question of inverse variation. More men, number of days required is less. Less men, they take a lot more number of days to complete the same work, that is the building of the same road. So incomplete work, how much work is still left incomplete after 60 days? That is 1 minus 1/4, right? If the entire road I consider as 1, then only 1/4 of it is complete in the first 60 days. So 4 minus 1/4, which is 3/4. Still 3/4 of the road needs to be completed. Now what are the remaining days? That is definitely 200 days minus the first 60 days which are already over. So number of days left to complete the entire road is 140 days. Now we know, I have just written the given statement here, 1/4 of the road can be built in 60 days by 140 men. Now 1/4 of the road can be built in one day by how many people? If in one day I want to complete the same work, that is 1/4 of the road, which was completed by 140 men in 60 days, means I need a lot more people. In one day I'm trying to complete 1/4 of the road. Definitely it means 60 days into 140 men. That is the number of people that will be required if I want to complete the same 1/4 of the road in one day. So 0 0 I will write down here. 6 4s are 24. 2 gets carried over. 6 1s are 6, plus the carried over 2 is 7 and 8. 8,400 men will be required in one day to complete 1/4 of the road in one day. Now if I'm trying to complete the entire road in one day, again definitely lot more than 8,400 men is required. How many men? 1/4 of the road is completed in one day by 8,400 men. So complete road is how much? 4/4, that is one whole, the complete road. So for this, to make it 4/4, this side also I need to multiply that 4. So 8,400 men who were able to complete 1/4 of the road in one day, 4 times more will be required to complete the entire road, which is 4/4, right? So if I multiply with this 1/4 on this side, I multiply, okay, not right here, but I'll write it here, to complete 1/4 into 4, right? If I want to do this much work in one day, there is a complete road, 4 times of 1/4. This is equal to 1, right? I'll get 4/4, which is equal to 1. So same 4 needs to be multiplied this side also. Are you able to get what I'm trying to say? So how much will be the number of men required? 0 0 first they will be written as it is. 4 4s are 16, 1 gets carried over, 4 is 32, 32 plus 1 is 33. So 3,600 men, these many number of men will be required to complete the entire road in one day. Now we know that road does, the question is not asking us to get the road completed one day. It is asking the complete road needs to be built in 140 days. So definitely now the number of men will be less. Then how many number of people are required? That is 3,600 men, because 3,600 men are required. I'm repeatedly repeating it so that you get the flow, how we are solving, how we are approaching the questions. Please be with me. Please try to understand. Please focus on whatever I am saying. So 3,600 men are required to complete the entire road in one day. So in 140 days, definitely less number of people will be required, because the work can be stretched over a number of days, 140 days. So definitely lesser men can complete, lesser than 33,600 people can complete the work. So I'll divide by 140 because that is the number of days we still have. So if I divide 3,600 by 33,600 by 140, then what we will get? I'll try directly with 14 here. 14 ones are 14. Here up it will be 14 twos are 28. Now 33 minus 28 is how much? 5. So it becomes 56. Now 14 fours are 56, and there is this 1 0 here which I cannot forget. So 240 men will be required to complete the work in complete road to be completed in 140 days. We need 240 men. But do we have the complete road to be completed? No. 1/4 of the work has already been completed. We just need remaining work, that is 3/4 of the road to be completed in 140 days. So how do we find that? 240 into 3/4, right? If the entire road, one road gets completed by 240 men in 140 days, then 3/4 of the road will be completed by 240 into 3/4 men in 140 days. So 4 ones are 4, 4 6 are 24, and the 0 comes here, the 0 here. So what we have? 60 into 3. So that will be 180 men. Additional men required will be, already we have got 140 men. So how many additional men will be required? We have to find out by subtracting 180 from 140. So, 140 from 180. So 180 minus 140 is 40. So additional men required will be 40. 40 more men need to be employed so that the entire road gets complete, not the entire road, but 3/4 of the road which is left is completed in 140 days.